Hi, this is Bhavani. I'm working as a associate professor in CSC department of BBC Engineering College. In this session, I would like to explain the purpose of Turing machine in formal languages and automata theory. Okay, so in this, how we can design the Turing machine and what is the main role of that particular Turing machine and how we can say after applying that particular some inputs to that particular machine, um, that particular input is either accepted or rejected. Okay, that is the main thing. So that means after creation of any machine, we can simply apply some inputs and we can simply get some output. Okay, so if that particular output is reaches to our target, then automatically we can simply say that is accepted by that particular machine. If it is not reached to our target, then automatically we can simply say that is the rejected. Yes, that means we can simply modify some inputs and again apply to that particular machine until and unless in order to reach our that target. So in this, what is the main how we can design that particular Turing machine? Okay, so the basic definition of the Turing machine in formal languages automata theory is it is the machine format of unrestricted languages. So that means this type of Turing machine simply accept any language. That means there is no restriction to define a particular language is known as unrestricted languages. So all types of languages are accepted by Turing machine. That is the main important thing in this type of Turing machine. So coming to the mathematical explanation of that particular Turing machine in this, it is basically 7-tuple format. Yes. So this is the 7-tuple format. So in this, what are the 7 tuples for that particular machine? So that machine can be represented as M. So what are the 7 tuples in this? First one is Q, next sigma, next tau, del, Q naught, and next one is B. And last 7th tuple is F. Okay. So in this, the first one is Q. So what are the different types of otherwise what are the different states while performing something operations on by taking that particular input in order to getting that particular output. So what are the different states that can be represented as Q, finite set of states, and next one is input alphabet. So this input alphabet, that means what are the different types of symbols that are present within the given input string that can be represented as sigma. And next one is in a particular tape, we can simply store that particular input symbols that can be treated as finite set of allowable tape symbols. So that can be represented as tau. And next coming to this is the most important tuple in any machine, that is known as transition function, that can be represented with del. Okay. So after reading that particular input symbol, the finite control decides whether that state is transferred to the next state, otherwise placed in the same state. That is known as transition function. The functionality of what are the main important tasks to transfer from one state to another state, that can be represented as del. And among all those states, we can simply say this is the initial state and as well as this is the final state. For example, consider the BTech level. So the first initial state is can be treated as a first year, and the next final state is that can be treated as a final year. Okay, in between first year and final year, the middle states are, so that is a second year and as well as third year. After completion of the first year all subjects, we can simply go to that particular candidate is transferred from first year to next state, that is a second year state. And after completion of the subjects, so whatever the subjects that are related to in the second year, after completion of that particular subjects to that particular by you that particular candidate transferred from second year to third year, and as well as in the similar way from third year to final year. But the initial state of that particular BTech candidate can be treated as a first year, and the final state of that particular BTech candidate can be treated as a state is final year state. Okay, so that means we can simply concentration on first year and as well as final year. So that means among all those first year, second year, third year and final year, initial state is first year and final state is final year. In the similar way, in this case also the Q0 is the initial state and as well as F is final state. Okay, so what is this B? What is the meaning of representation of that particular B? So that means in this, the entire input symbols are stored in the some input tape. Yes, the starting of that particular input string and as well as ending of that input string is marked with blank symbols. Those can be treated as end markers of the given input string. So that can be treated as a B. So that's why the Turing machine is a 7-tuple format, that is Q, sigma, tau, del, Q0, B and as well as F.